Telling the ongoing story of Penn State and the surrounding community, this is In Motion. Billions of light years from our own galaxy, immense releases of energy randomly take place. These releases are called gamma ray bursts, or GRBs. Several theories have arisen to explain GRB events, from supernova explosions to neutron stars merging. Whatever the explanation, GRBs can generate in 1 second the energy our sun generates over its entire lifespan. That, combined with their distance from our own galaxy, make these occurrences very unique events to study.
Because they're coming from galaxies that are so far away, it takes literally billions of years for the gamma ray emission to come from that star to us. So all of these bursts are already on the way here. We are indeed looking back in time when you look at these distant objects in the universe. And since gamma rays are coming from halfway across the universe, we're looking way back in time to the early years of the universe.
Realizing the potential for discovery, scientists set out to develop a new way to examine GRBs in greater detail. A global partnership led by Penn State and NASA brought about the SWIFT project. Dr. John Newsick of Penn State University explains.
To study gamma ray bursts, we decided the best thing to do was to have a mission with 3 different instruments. One, a gamma ray detector, of course, to find the burst, and we have the Burst Alert Telescope built by Goddard Space Flight Center, which discovers the burst with about 5 times more sensitivity than any previous detector. The second thing is an X-ray telescope built here at Penn State with help from our colleagues in the United Kingdom and in Italy. And that makes a precise X-ray position of the glow left behind after the explosion occurs. And the third thing to finish the story is our UV Optical Telescope, again built by collaboration led by Penn State with colleagues in the United Kingdom fabricating the detectors. The purpose of the UV Optical Telescope is not only to measure the brightness in the UV optical regime, but also to give us the most precise position on exactly where the gamma ray burst happened. And that will give us the ability to find it to within 1/3 of an arc second, which is very significant accuracy of locating the gamma ray burst. Penn State is the lead university partner, and we've had responsibility for somewhat over $30 million of activity on SWIFT. The 2 primary instruments that we led were the X-ray telescope and the UV Optical Telescope, or UVOT for short. The other major thing we're doing is we're providing the Mission Operations Center. And so I personally will be the mission director, and we have responsibility for operating SWIFT. Penn State is the lead university partner because we are the first of the group. We've had responsibility for building 2 of the instruments. We've had responsibility for providing the Mission Operations Center. Penn State is providing the only facility devoted to the study of SWIFT. It's the only university that has such a large commitment and large involvement in the SWIFT program.
With the vast amounts of data that will come from the SWIFT spacecraft, researchers hope to answer some big questions.
Gamma ray bursts may actually be at such great distances, coming maybe from the very, very first generation of stars, that would allow us to sort of check out the universe 10, 11, 12 billion years ago. How it happened could be very important for understanding how the elements in the universe were formed, how the planets were formed. And of course, people are made of elements like carbon, oxygen, and nitrogen, and the universe has all these stars and galaxies. And by studying gamma ray bursts, there's the chance that we will be able to understand how that process occurs.
To find out more about the SWIFT project and to receive regular updates, check out this NASA website and check out live.psu.edu.